So in this problem we're still on statics, so things that are not moving, you should know that by now. So we are given this problem that we are going to try out here. Okay, let me read it. Okay, one end of the uniform 5-meter long rod weighs this much and is supported by a cable. The other end rests against the wall where it is held by friction. There is friction just here. And okay, held by friction as the diagram below as this diagram. The coefficient of static friction between the wall and the rod is this much. Okay, determine the minimum distance from A at which an additional weight G, which is equal to this, hang without the rod. Okay, they want to add some weight again in the system, so they want us to find where they should put this weight so that this thing doesn't slip off. Okay, so for this thing to remain static. So how are we going to do that? You know that static sum of forces along y is equals to 0, sum of forces along x should equals to 0, and sum of moment about any point should also equals to 0. This is our static equations. If you have all these statements true, this one true, this one true, this true and true, that implies that whatever thing is static, it is not moving at all. Okay, because we know that we want this thing not to move. Okay, we want it not to move, so we're going up. So if we don't want it we don't want it to move, so we want it to have this and this and this. Okay, let's look at forces along y that should equal to 0. Sum of forces along y that should equal to 0. Okay, I have force here. I will call it, let me just remove all this thing that I have in here. I have a force here, I'll just call it T y, and I have a force going this way, I'll just call Tx. And here this thing should pull it down, so we have friction going this way, I want to call it force friction static. And here in the center I have just Fg, the weight of the rod, and I have another Fg, let me just Fgx that needs to be put loaded here, but we don't know how much it needs to be loaded away from A, of which this is what we are trying to work out. Okay, so I was looking at the forces along y, so I prefer choosing let me say this way is positive. Most of the time I love that. And let me say this way is positive also. And let me say moments that are which way? Let me just take counterclockwise as positive on my moments. Okay, this is my sign choice. You can put any sign choice of your own, you're still going to land in the very same answers. So you can do any signs and comment in the section if you have any problems with that. Hopefully you won't. I trust you. Okay, the next thing is going to be, okay, sum of forces along, we'll have Ty, of which will have to be positive, and we'll have Fs, this one will have to be positive, and we'll have Fg, the weight of the rod, of which is 100. Let me just plug it in just to save my time. And I have also another 100 load that they want to add. We have another 100 they want to add. Let me just sum this just to make it 200 newtons. Okay, I've covered this load, this friction, and this. I think I've covered all the force along y. It should equals to 0. So from now I can just say 200 newton. Let me not use units. It should equals to Ty plus Fs. Okay, very good conclusion to have. Okay, let me do something else this side. What if I look at sum of forces along x, of which they should equal to 0 again, implying staticness of the structure? Okay, so if I'm looking at sum of forces along x, I have this. I have normal force going this way here, reaction, normal force, which is positive according to this. So we'll have normal on the wall, which is positive. This side I'll have T. T is going this way according to this, it's negative. I'll have negative T X. I have another force here. I don't see any. You will tell me if you see one. I have this, and that's all. I think that's all. Okay, 0 now. So this tells me that my normal should equals to my Tx. Okay, that is very good to know. But I also know my normal, right? My normal is mu s and is it? Okay, let me just hold it here. Oh yeah, this is just my normal. Okay, yeah, that's all. I was trying to put in friction in here, of which I should put it here. Okay, let me not do that now. Let me just skip some lines and just go to the sum of moments along some point of my choice. You can choose any point, but you're trying to choose a point that we have a lot of unknowns, which I'll just choose. I'll take this point O. I'll take my moments around about that point, should equals to 0, right? Okay, let's go there and look what is happening. So all the forces that are here, they won't change, they won't add to my moment because they don't have arms, right? We talked about that on the past video. And here now we do have the first moment by the force by the weight that they want to add, that we don't know where to put it, of which you know that force, remember the moment is force cross arm, right? X. For this one, we know the force, it should weigh 100 newtons, but it should be X away from A. That we don't know. Okay, so good. Let me look at the direction. It will move our thing like this, clockwise, and according to this, I'm expecting it to be negative. Okay, because here I chose counterclockwise as positive, and this one is clockwise, negative. And I also have another 100 that is, because we're looking at this beam, it's uniform, it's in the center. This beam was given to be 5 meters, so the center is going to be 2, 5, right? So it's going to be 2, 5. I didn't put a sign here, if you can notice, because I don't know it, right? Let me just find it out. This thing is going to pull this thing down. It's going to cause a clockwise, and here that should be negative again. Okay, I'm out of room. Take this to the side. Okay, good. We've just included all the weights, and now we still have something that is here. Our Ty is going to be, where is it, where it takes it? It goes up, so it's the only positive one. Plus Ty, let me just call it T. Where is it? This is it, right? Okay, it's going to be sine 37. Sine 37 should equals to 0. Let me go there. Did I miss any force? I did do a moment for this. 1, 2, 3. I've done for all of them. This is where I am right now. Okay, but I could, from here I could solve the x, but the t is the problem. Okay, that's cool. We're fine with that. We can just take all this to the other side, of which is going to be 100, 2.5 minus tension sine 37 all over negative 100, and here I'll have x. So I'm done. Yeah, but I have a problem, obviously. I don't know this t. Where will I get t? We don't know. Let's just find out. Okay, we know that here we have something about t. I don't know what to do with it, but it's there. Okay, let me come back here. I had ty. Let me just not use ty. Where is ty? Here is ty. It's obviously the sine, because it's the opposite, so it's going to be t sine 37 7. Okay, and plus friction. What is friction? Friction is normal cross static, right? But I do know friction, I do know n is equal to tx. What is tx? Tx is here, right? So it is cos, right? It's going to be t cos 37 times static, right? And I can come with this and put it just here first for this. Okay, so I can just add it here. It's going to be t cos 37 mu s, right? That should equal to 200. Okay, we are close to what we want. If I can see here, it's look like we have everything. We can just solve from here because we know this, it was given. We can find t now. I'll just factor t out. Obviously, if I take out t here, I'll have sine 37 for room. Let me just take you just in this corner. I don't need you anyway. I was using you, I don't need you now. Okay, plus if I take out t here, it will be mu. What it was given here? Static, which was 0.75. 0.75, that was like my mobile number. Okay, 0.75 cos 37 is equals to 200, and I can close here and find t by dividing by this thing of 200. If I did the good math, obviously I hope I did, I got 166.55678 depending on the segment figures, but I hope that you just keep this like this because you're going to use it anyway. And I have tension now. I come back here, I already have an answer, I was just missing tension, right? Let me just plug tension here, this number here, and push in the calculator. Hope that I get the correct answer again. And this is my answer from punching in the calculator. It's unfortunately negative. That means it's not from A to X, but it is from the end of the beam this way, right? Because we want this, we just have to minus it or add 5 from it, and our AX distance is going to be adding 5 here, and I'll get 3.502363766 meters depending on the significant figures that is required of you. And this is the correct answer. If they put this thing, this new weights are about this distance that we just got here, about this side. I hope this thing can hold, can still be static.